Good morning, students. Today we are going to see type checking, which is the next point in the syllabus of unit number 5. Up till now, we have seen how the parsing takes place in unit number 4. After that, only parsing is not sufficient, and that is only generating syntax tree is not sufficient. We have to give the meaning to the particular tree after parse tree generation, which is the next step with respect to semantic analysis. Now, how to do that we have seen. But while doing semantic analysis, type checking is very important. Okay. A compiler must check that the source program follows both syntactic as well as semantic conventions of the source language. This checking is actually this type of checking is a static checking, which detects and reports programming errors. Okay. Now some examples of static check is, out of which the first is the type checks. Okay, which checks whether the computer in this type of type checking, a compiler reports an error if an operator is applied to an incompatible operand. For example, if an array variable and function variable are added together, okay, in that scenario it should generate an error. Second type of check is a flow of control check. Here, as everybody knows, flow of control means what? With respect to looping, with respect to switch statements, this is going to happen, right? So statements that cause flow of control to leave a construct must have some place to which to transfer the flow of control. Where to transfer the flow once the particular break statement is encountered. Where to transfer the flow when the particular loop is ended. So these type of things should be taken into consideration. With respect to that, for a particular example we can take is an enclosing statement such as break does not exist in switch statement. Such type of error should be generated. You can see here the position of type checker basically. As I already said, first of all the token stream is given as an input to the parser. But after that the parser generates the syntax tree or the parse tree for the particular token stream. After that, once the syntax tree generated, it is given as an input to the type checker. Then once again after type checking, the syntax tree is revised, and after that it is given to the intermediate code generator, and at the end it is intermediate representation. Okay, a type checker basically verifies that the type of a construct matches that expected by its context. For example, arithmetic operator mode, it requires integer operands, right? So a type checker verifies that operands of mod have type integer. Type information gathered by a type checker may be needed when code is generated. Okay, so basically the type systems and type expressions. Next point, basically what is type system? A design of a type checker for a language is based on what? Information about the syntactic constructs in the language, the notion of types, and the rules for assigning types to language constructs. For example, if both operands of the arithmetic expression which is given to you is of type plus, minus, multiplication, or of type integer, then the result is also of type integer only. If plus, minus, multiplication is performed on float, but obviously the output should be a float. So such type of type checking should be done. Now, next is a type expressions. The type of language construct will be denoted by a type expression. A type expression is either formed by applying an operator called type constructor to the other types of type expressions. The set of basic types and constructs depending upon the language needs to be checked. Let us suppose we'll see some type of constructs here, out of which the first is what? Array. Okay. Now basically whenever we are defining these type expressions, first is what? The basic types like as boolean, character, integer, real are the type expressions. And the special type, that is type underscore error, it should generate a type checking error. Since expressions may be named, a type name is a type expression basically, and a type constructor applied to a type expression is a type expression. Okay. Now as I said, the constructor will include what? First of all the arrays. Okay. If T is a type expression. Then array of I comma T is type expression denoting the type of an element with the element of type T. An index set as I, because everybody knows that the array has an index. So what should it include? Array into bracket I comma T, where I specifies the index and T specifies the type of the array. Next is the product. If T1 and T2 are two expressions, then the Cartesian product, but obviously will give us a type of expression, that is T1 Cartesian product with T2. Third is the records. The difference between a record and a product is that the names. First of all, the record type constructor will be applied to a tuple formed from field names and field types. Okay. In a record, I can have arrays, right? Array of records. Just now as I said, a particular record can have n number of records. That is, it will have array of records, n number of records, which are specified in array. Okay. Next is pointers. If T is a type expression, then pointer of T is a type expression denoting the type pointer to an object of type T. For example, variable P, row declares variable P to have type pointers, that is row. Next is the functions. A function in a programming language maps a domain type D to a range type R. The type of such functions is denoted by the type expression D. Okay. So we'll see some simple type checker. A type checker for a simple language checks the type of each identifier. It will check the type of each identifier. Let us suppose integer, character, then whatever things I am applying, array, it's array or integer, that is text. The type checker is a translation scheme that synthesizes the type of each expression from the type of its sub-expression. The type checker can handle arrays, pointers, statements and functions. Here on the slide you can see, let us suppose in this scenario, let us considering the grammar. P gives D, E, then D, then integer T. Likewise it is defined. Then translation scheme will be what? Here you can see D gives ID, then D is also D and D is also ID as T. Whereas here what? Add type id dot entry comma dt dot type. We have to specify the type as well as the value is within that. Okay. So likewise it is specified. In the above language you can see there are two basic types, char and integer. Okay. Then type error is used to signal the error. Type underscore error will be used to signify the error. Whereas the prefix operator builds a pointer type dot example. Then this integer leads to a type expression pointer, that is integer. Okay, or output will be what? Integer. Next, type checking of expressions. Here, in the following rules given on the slide, the attribute type for E gives a type expression assigned to the expression generated by E. E gives literal. E dot type is what? Char. Next is what? E dot type is signifies num, so it is integer. Next is a ID, so it's lookup ID dot entry. It's going to vary. Lookup of E is used to fetch the type saved in the symbol table. Entry pointed by the E. Even, next is even mod E2. Then E1 is of type integer. E2 is type integer. If it is not integer, then it will give error. Okay, because both are mod, then it should be applied to the same type of the variable. E1 of E2 means what? If E1 should be an integer, E2 should be an integer, because E1 is specifying the array with respect to E2. E2 is the value inside the E1. So both should be arrays. So both should be integer. If no, it is not there, then it should give the error. Next, fifth one, E1 address pointer. If E1 dot pointer is a pointer, then it should be, if it is not a pointer, it is not a pointer to the correct value, then it should give the type error. Okay. As we already said, the postfix operator yields the object pointed by its operand. The type of E is a type T of the object pointed by the pointer.